Our second video is going to be on rational expressions on chapter 7. So we're going to go again through the review guide here, starting with number 11 on the chapter 6, chapter 7 review guide. Number 11 starts with a variable x and y vary inversely. Use the given value to write an equation of x and y and find y. So we're inversely, depending on how you were taught it, is y is equal to k over x, or you actually could think about it as xy equals k. So now you are given a situation in which x is 4 when y is -5. So find k. So putting it down here in the bottom equation, if x is 4 when y is -5, then k has to equal -20. So writing an equation now, y is equal to -20 divided by x, and then they give you a situation when x is -2. So y is equal to -20 divided by -2. So for this particular situation, y has to equal 10. Now we're going to get a bunch into graphing rational expressions. There is things that you have to worry about are vertical asymptotes, horizontal asymptotes, oblique asymptotes, and holes. Let's talk about when each one of those occurs. A vertical asymptote occurs is when the denominator is equal to 0. A horizontal asymptote occurs in which there's a shift. If the degree of the top is the same as the degree of the bottom, if the degree of the top is smaller than the degree of the bottom, or in this case, when it's subtracting 3, so now you got a translation down 3. Oblique asymptote only occurs in which the degree of the top is larger by 1 than the bottom, and holes only occur if something cancels. So here we go. We'll go through this question. So now the denominator has an x minus 1. So when does that equal 0? That is your vertical asymptote. So I'm going over to the graph. You're going to have a dotted line when x equals 1. Horizontal asymptote. Remember what I said about the degree of the top and the degree of the bottom, but this was actually a shift. So the degree of the top and the degree of the bottom, this would be a y equals 0 normally, but since it's -3, you're talking about y equals -3. So -3 going across. There is no oblique asymptote, and there is no hole for this particular problem. Now, graphing this situation, now you're talking about where is it going to be graphed at? Is it going to be graphed in the upper right? Is it going to be graphed in the lower left? Is it going to be graphed in the upper left or lower right and stuff? And really all you need is one point. So like if I put 2 in place of x, for instance, if I knew x was 2, then y would actually equal, plugging that in for x, you'd get y to equal 2. So you're talking about the point 2, 2 right here. Well, if that is the case, then it's going to also go, and I probably should have switched colors for you, but it's also going to go along the asymptotes then in both directions. You don't need more than that. That is all we're expecting when you go to graph this. Do you have the vertical asymptote? Do you have the horizontal asymptote? And do you know what area it's? Now, I did do the graph on the right-hand side of the vertical asymptote. Now let's talk about on the left-hand side. Let's say I plugged in 0 for x. I believe you get -8. So it's 0, 1, 2, 3, 4, 5, 6, 7, -8. And so again, I know the region that it's going to be graphed in. I don't necessarily need a bunch of points when making these graphs. So again, the same questions you're going to ask every time. Vertical asymptote, horizontal asymptote, oblique asymptote, and hole. Since there's nothing being added or subtracted at the end, okay, you don't have the translation there. So vertical asymptote, and I'm going to change colors here, is when x is equal to -3. That's the value that causes the denominator to equal 0. Since the degree of the top is smaller than the degree of the bottom, eventually you'll end up getting a y equals 0, horizontal asymptote. So y equaling 0 is if the degree of the top is smaller than the bottom, x equaling -3. Since the degree of the top is not bigger than the bottom, you don't have to worry about the oblique asymptote. Nothing cancels. You don't have to worry about the hole. So now it's a matter of getting 1 point in a region to go ahead and graph this. And again, what you decide is your XY point. You can pick any number you want here. So I picked -1 for x because it kind of works out pretty nice. So if I put -1 in for x, I get -1 for y. So -1, -1 puts the point right there, which means this is going to be graphed along the asymptotes in this area. Now I'm going to pick a point on the other side. For instance, if I pick a number like -4 and plug that in, I end up getting -2 over -1, which is 2. And again, I don't need a lot of points here. Ultimately, I just need a point to show me that it's going to be along the asymptotes. Please do not cross the asymptotes as you go here. And ultimately, that's the graph. All right, a little bit more complicated one. I'm still going to do vertical asymptote, horizontal asymptote, oblique asymptote, and whole. The bottom is factorable. So I end up getting x minus 4 and x plus 3, which means I have more than one vertical asymptote. I have a vertical asymptote when x equals 4, and I have a vertical asymptote when x equals -3. So when I go over to my graph, I'm going to have multiple. I'm going to vertical asymptote at 4 and a vertical asymptote at -3. Since the degree of the top is smaller than the degree of the bottom, we're back to a y equals 0 still. Horizontal asymptote. The degree of the top is not bigger than the bottom, so you won't get an oblique asymptote, and nothing cancels, so you won't get a whole. We're going to get to that in just a few minutes. Now, you'll notice that you have multiple asymptotes in your vertical asymptotes in your picture. So ultimately, when you do your XY chart, you ultimately need a point on either side of both vertical asymptotes. Now, when you're plugging in your points here, I'm going to plug a point on either side of -3. So we're talking about like -2 and -4. Plug those in for x, and then I'm going to plug in 3 for x and 5 for x. And now, ultimately, I don't care. We're probably going to get some decimals here. We're going to get some fractions here as we go, but I'm just looking for the area in which it is graphed. All right, so now let's say I plug -2 in for x. I'm going to get 5 times -2, which is -10. And then I'm going to get -2 minus 4, which is -6. -2 plus 1, which is 1. So I'm going to get -6. So this ends up being positive 5/3. So when I graph that point, -2, positive 5/3. So right about there on the graph. Now I'm going to put -4. I'm going to do one on the other side. I'm going to put -4 on the top, so I get -20. Now I'm going to get -4 minus 4 is -8. Minus 1 will be +8. So this is going to end up being a negative value now. So we're going to divide both sides, top and bottom. So I'm going to get -5 halves. So 1 down here. So what's going to happen is this is going to get graphed here. That's what I know so far. The middle is going to get a little bit complicated. When I plug 3 in, I'm going to get 15 over 3 minus 4 is -1. 6, I get -6, which does reduce. Reduces to -5/3. So now wait a minute. I ended up having one on the bottom of the horizontal asymptote and one on the top of the horizontal asymptote. What that means, because we ended up having an x on the top, this is going to zigzag. So those of you talking about your trig functions, notice you have 2 asymptotes. This actually makes a zigzagging zigzag in between and crossing the horizontal asymptote. That can only occur between 2 asymptotes. And then the last one, 25 on top, I end up getting over 8, which is a positive value right here. And so now I'm talking about along the asymptotes in both directions. Next one. I still want to get vertical asymptote, horizontal asymptote, oblique asymptotes, and wholes. And immediately I look and see, oh, wait a minute, that something looks factorable. So the top is factorable to be x minus 3 and x minus 2, which means something cancels. That's an immediate cancel those out and write yourself whatever value of x causes that to be 0 is automatically a whole in the graph. So now here's what you're left. You're left with y equals x minus 3, which is not a rational expression. So no longer vertical asymptote, horizontal, oblique asymptote. I just have a line. Notice that I skipped a point there. I have a line that has a hole in it when x is 2. Next one, vertical asymptote, horizontal asymptote, oblique asymptote, and whole. The degree of the top is the same as the degree of the bottom. So the vertical asymptote right here is x equals 3. The degrees are the same, so what you do is you go to the coefficients. Notice the coefficient on the top is 3. The coefficient on the bottom is 1. That's the number in front of x. So this is y equals 3. So when I go over here to graph it, I'm going to have a horizontal asymptote at y equals 3, a vertical asymptote at x equals 3, no oblique, and nothing canceled, so no whole. Again, I'm going to test a value. I want to be able to graph this. So I'm going to test a value on the right-hand side of 3. So basically, I'm going to test a point. I'm going to put 4, and then I'm also going to put in 2 when looking at this graph. And so when I plug 4 in, I get 12 over 1, which is 12. When I plug 2 in, I get 6 over -1, which is -6. So plotting just those 2 points, 4, 12 is off the graph, which doesn't matter because I'm just going to graph it along the asymptotes, and 2, -6 is on the graph, but that's all I'm looking for. All right, last but certainly not least, this one's probably the most challenging one that we're going to have in this particular section. We got a vertical asymptote, horizontal asymptote, oblique asymptote, and whole. So I factor the top. It's a difference of squares. I can factor the bottom, so I get +3 and -1. So right there, that cancels x equaling -3 as a whole. What I am left with is still a rational expression. So I'm still going to have some questions here. The vertical asymptote is when x is equal to 1. Remember, when you're looking at the vertical asymptote, it's the value that makes that, the bottom, 0. The degree of the top is the same as the degree of the bottom. So y equals 1. That's the coefficients in front of both of these. No oblique asymptote. So over here on the graph, I've got x equals 1, vertical, y equals 1, horizontal, and then I go to graph. I test a point on either side of x equaling 1. So I'm looking at when x is 2 and when x is 0. So when I plug 0 in, I get +3. And when I plug 2 in, going back up to the original question, I'm going to get -5 over 8. So +5, so I get -1. So going over here now to the graph, I get 2, -1. So there's one side of the graph. 0, 1, 2, 3. Now, here's the one little trick you got going on, and I'll just graph the whole thing and then show you. At -3, right here, there is a hole. Remember, the hole has to be when x is -3. So on the graph right there, and I probably didn't do a very good job because I came really close to my asymptote, but ultimately it's a graph along the asymptotes with a hole when x is -3. All right, last thing, we haven't had an oblique asymptote yet. Vertical asymptote, horizontal asymptote, oblique asymptote, and whole. Now, the top doesn't factor, and therefore there is no whole because nothing cancels. The degree of the top is bigger than the bottom. So let's talk about vertical asymptote first. Vertical asymptote, x equals -1. It's the value that causes the denominator to be 0. Since the degree of the top is larger than the bottom, there's an oblique. How do you get the oblique asymptote? Long division. This only occurs when the degree of the top is larger than the degree of the bottom. Now, going back to first semester long division, what value goes into the first one? So x goes into x times x gets you x squared. X times 1 gets you +1x. Change the signs because you're subtracting and pull down the next one. And I'm going to give myself a little more space here. What times x would get me x? +1. Change the signs, I get a remainder of 6. Now, the remainder is meaningless to the actual oblique asymptote, so this is y equals x plus 1. So that means I'm going to graph the line, y equals x plus 1, and that is my oblique asymptote. My vertical asymptote is x equals -1. Just like before, I want to test a point. So I want to test a point on either side of the x. So we're talking about -2 and and 0. And so when you plug 0 in, you get negative 5. So 0, 1, 2, 3, 4, 5. And so it's along this asymptote and then along the oblique. And then when you plug negative 2 in, you get negative 5 over negative 1. You get positive 5 this time. 1, 2, 3, 4, 5. And so again, it's along this asymptote without crossing either one. Multiplication of rational expressions now. If they're all binomials, here's what I would suggest. Multiply straight across. So 24 x to the, using rules of exponents, x to the 8th, y to the 5th, over 60, x to the 5th, y to the 8th. Now, it's basically having 3 problems in one here. 24 divided by 60 reduces to 2/5. X to the 8th over x to the 5th, and y to the 5th over y to the 8th, and that's it. So if they're binomials, just multiply straight across and then reduce. Now the question then becomes, what happens if they're not all binomials? Well, and division. Division means you have to multiply by the reciprocal. So that right there is the first step. And now it's about our factoring skills. So if you struggled on factoring, this particular section is really going to be a bit of a struggle for you. This factors to be x plus 3 and x minus 2, factors of negative 6 that would get you 1. This one you can take a 4 out, greatest common factor. That's a binomial. This one is the difference of cubes, and I probably should show my work here a little bit. X cubed plus 3 cubed. Factors to be x plus 3, first one squared, change the sign, multiply the two together, last one squared. So I ended up factoring that one. Now, once you have everything factored, let the canceling begin. X plus 3 can cancel with x plus 3. X minus 2 can cancel with x minus 2. 4 is a binomial. It can cancel with 8 to be 2. So the answer is 2x over x squared minus 3x plus 9. Lots of factoring. Okay, tons and tons and tons of factoring. The first one, I'm going to factor 3x squared plus 7x minus 6. I'm not going to tell you how to factor. Ultimately, this factors to be 3x minus 2. Try this again. 3x minus 2 and x plus 3. The bottom one factors twice, actually. You can take a 2 out, and then you get x minus 3 and x plus 3. The next one factors, you can take a 3 out as a GCF. And then the last one, you can factor again, 3x minus 2 and x plus 6. So again, your factoring skills, and if you're struggling with factoring, talk to myself, talk to Mr. Bone, talk about factoring, and we can go through that with you. 3x minus 2. Now, anything that's on the top can be canceled with anything that's on the bottom. You just can't cancel straight across. So the 3x minus 2 can cancel with 3x minus 2. X plus 3 can cancel with x plus 3. X minus 3 can cancel with x minus 3. So I end up with a 3 on top, a 2 on the bottom, and an x plus 6 as my answer. Adding and subtracting. Adding and subtracting is different because you must have a common denominator. The bottoms must be the same when you go to add and subtract. So I need to come up with a common denominator between 6x and 2y squared. So 6 is the common denominator for the number. So they both need an x and they both need a y squared. Next, what do I need to multiply the first fraction by to get to that denominator? So I need to multiply the first one by y squared. I need to multiply the second one by 3 and x. And that's literally what we have to do now. The denominator is the same. Add like terms on the numerator. Now, there is no like terms, so ultimately that's my answer. Again, common denominator. So the common denominator is both binomials. So the first one needs to get multiplied by an x minus 3. The second one needs to get multiplied by an x plus 1. Since the denominators are the same, I need to subtract the numerator. So be careful there. 4x minus 2x is 2x. Negative 12 minus 2 is negative 14. Now, this answer is fine, but ultimately you should always try to factor the top just in case something might cancel. So this was the answer that I would probably expect, but both answers are actually correct. All right, so I need a common denominator. I'm looking at these two, and this is factorable. So when I go to try to find my common denominator, I always want to make sure it's in factored form before I decide what is the common denominator. So the common denominator in this one is a 2, an x plus 6, and an x minus 4. You do not need both of them. Just because both of them happen to have an x minus 4 doesn't mean that I need it more than once. So now, the first one, what do I need to multiply by? Well, I need to multiply by a 2 and an x plus 6. The second one I need to multiply by, oh, I'm sorry, try that again, just a 2. Sorry about that, just a 2. So 10x minus 14. The second one I need to multiply by the x plus 6. 3x plus 18. The denominators are the same. Add the numerators. 13x plus 4. Solving. I want to solve this particular equation. Now, there's two things to know about when you're solving rational expressions. One, if you have a fraction equaling a fraction, you can do cross multiply it to solve. If you don't have that, you need to get rid of the denominator, and you have to always worry about what's called excluded values. So 3x times x plus 2, I'm going to cross multiply on this. 1 times x plus 12, 3x squared plus 6x equals x plus 12. 3x squared, I'm going to subtract x and subtract 12. And now, again, you're talking about your factoring skills. 3x squared plus 5x minus 12, I need to be able to factor that. All right, 3x and x, again, testing your factoring skills here. Minus 4 plus 3, and then set the parentheses equal to 0. So 3x minus 4 equals 0, x plus 3 equals 0, x is equal to 4/3, and x is equal to negative 3. If you need help with this factoring step, please make sure that you understand to talk to Mr. Smith, talk to Mr. Bone, and talk about how you need to factor. Next one. If you have more than one fraction, you need to multiply everything through by the common denominator. So in this case, the common denominator is 3x. So everything in this question needs to get multiplied by 3x. Well, if I multiply the first fraction by 3x, I end up getting x times x plus 7 because the 3 and the 3 cancel. In the second one, the x's cancel. I'm left with 3 times 5. And in the last one, the x's cancel again. I'm left with 45. Now, x squared plus 7x minus 15 equals 45. Subtracting 45. And you're back to your factoring skills. Again, x plus 12 and x minus 5. Set the parentheses equal to 0. X is equal to negative 12, and x is equal to positive 5. A little more complicated now. This last one does factor to be x minus 8 and x minus 6. So when I'm multiplying through by the common denominator, everything's going to get multiplied by x minus 8 and x minus 6. X minus 8 and x minus 6. X minus 8 and x minus 6. Sorry about that one. So now the first one, the x minus 8's cancel. I'm left with 14 times x minus 6. The next one, the x minus 6 cancels. I'm left with negative 5 times x minus 8. And the last one, everything cancels. I'm left with 82. Distribute. 14x minus 84, negative 5x plus 40. Add like terms, so 9x minus 44 equals 82. Add 44. I get 126. And divide by 9. I get x to equal 14. Last one. Common denominator. This middle one factors again, x plus 3 and x plus 5. So as I'm multiplying through by the common denominator, I got to multiply everything by x plus 3, x plus 5, x plus 3, x plus 5, and the last one's times x plus 3 and x plus 5. The x plus 5's cancel. I'm left with 2x times x plus 3. The whole thing cancels, and now here's a little twist. It's negative x squared minus x minus 10. That minus sign that's right there is still going to be there, equals x plus 3's cancel. I'm left with 3 times x plus 5. So I went from having all kinds of fractions to now having no fractions. Distribute. 2x squared plus 6x minus x squared plus x plus 10 equals 3x plus 15. Get everything on one side. So now I'm down to x squared plus 7x plus 10 equals 3x plus 15. Subtract and subtract. Going back to your factoring skills now. X plus 5, x minus 1. So I get x to equal negative 5 and x to equal positive 1. Now, some twist that we have not talked about in any other problem. Going all the way back into the beginning, looking at your denominator, you had x plus 3 in the denominator and you had x plus 5 in the denominator. X equaling negative 5 is what's called an excluded value. If I put this value into this, I end up getting a 0, which means you're dividing by 0, and you can't divide by 0, so that's called an excluded value, and the only answer is when x is equal to negative 1, or excuse me, x is equal to positive 1. All right, that concludes our chapter 7. Hopefully, if you have any questions or any concerns about any of that, please let Mr. Smith or Mr. Bone know, and they'll be able to help you out.